We are building the Fractals and Recursion project from the YByte Python curriculum, available at www.ybyte.in. We saw previously how we need to realign the turtle before the next level of recursion can be done. And all we need to do really is to turn the turtle right by, let's say, -2 times the angle, and then turn it right again by angle and move it forward, let's say, in the negative steps, so that it comes back. Now, I had a detailed discussion on how this thing works in the previous video, so do look at it if you haven't yet seen it. But with this, we are ready to implement in our code and sit back, enjoy the magic, because this little extra thing will take us from, let's say, just one branch on the right to this entire tree. Unbelievable as it may seem, but that is the truth. Previously, we had this simple one-level recursion code, which would give us this branch, assuming, let's say, angle is 20. Now, I am going to make my second recursive call. However, before that, I will make some adjustments as we have discussed. So I'll just go and say t.right, for example, -2 times the angle. I will then again call this function in the exact same way. So I just go and say, for example, let's say this, and then I'll have t.right, let's say angle, and t.forward minus of size. So that's what we have done. We have discussed this in the past, right? Now, magical as it may look, when I run this piece of code, notice my turtle is aligned. If I were to just go and call branch 108, in fact, I can sit back and relax, see the magic unfold as my turtle, let's say, ends up drawing this tree. It's kind of like very interesting to look at it. As you see, it's just going on and drawing the tree. Quite magical, really. It's going to come back and keep drawing those branches. Notice it keeps coming back, drawing the branches as we had discussed. Realigns itself nicely, and the entire tree is going to get generated. It came back almost to the root level now, and it's now again doing this. Of course, we can speed up this whole thing by using the tracer functions and so on, so that it just gets drawn in one shot. But there is certain amount of, let's say, pleasure in looking at this thing unfold, because just see the magic of recursion in how much code gets done, how much work gets done with just extra one line of code. Now let's look at some interesting variations. Let's say I want my branch on the right side to be a little bit longer than the left side. Well, I can make the, let's say, remember the second recursion is the one that's making the left side branches. So I can just make this, let's say, a little bit smaller. So when I now run this piece of code, let's say I align this and just speed this up a little bit so that it goes a little faster. So I just say make it 0. When I, let's say, do this, notice my tree seems like it's kind of swaying a bit to the right, because the left branches are a little bit small. Once it gets fully drawn, it will be more evident. The tree seems to be sort of swaying a little bit to the right. In fact, another interesting variation of this is when I make, let's say, both of these, say, becoming 0.6, so both will be equal, but I will use an angle of, let's say, 90 degrees. Now, this is actually quite interesting, quite unexpected to some extent. Let's see what happens when I do this. Now, again, I will speed this up by saying t.speed, say, 0. Now, when I run this same piece of code, notice it seems like a completely different figure, but in fact, it's just a variation of the tree that we have drawn, right? It's just a tree with a totally different shape. So the point is, you can play a lot with this. A lot of different effects can be created. In fact, we're just touching the tip of the iceberg here. You can, for example, change the width of these branches, so that it looks like a realistic tree. You can add some amount of randomness to this. All of those bonus ideas are possible. In fact, many things are possible, right? But the basic mechanism is what we need to understand. And that's what is happening in the 2 levels of recursion. Let me just illustrate this once again, so that we are clear. So let's say I gave branch 100, 0. I will, in fact, first call this from the, let's say, from the command line. This will recursively call the next branch 83, branch 64.2, branch 51.21. Now, we have seen this before, but the fun part happens here. My turtle realigns, comes back, and it draws the next line, 51.2. Again, comes back, realigns itself, draws this left. Now, remember, right happens first, so draws this right, draws this left, comes back, so comes back all the way here, draws this left, right, left, comes back, this left, right, and left. And then, of course, it comes back to where it had started from. Now see the similarity between this and the square pattern. Just see how similar they are in the logic level, even though the outcome is completely different. I hope you've enjoyed this journey. Again, this way of learning, going in depth into things, trying to understand how they really work, is, I think, quite rewarding, look at our website, www.ybyte.in. You will find many such activities and a lot of such discussion, which may be of interest to you. Take care. Thank you so much. Bye-bye.